1, 2, 3, 4, 5.
Yeah, it's good. I guess it's good now.
Yeah.
Fine. We'll start. Okay. Okay. Your good name?
Hello, Girish. My name is Tejasvi.
Okay. Tell me about yourself.
I have done. Hello, my name is Tejasvi. I have done my schooling in Hyderabad and completed my BTech in Hyderabad, the CVR College of Engineering. And after that, I worked in automation industry for 2 years in Epiroc Mining, which is located in Pune. And after that, I took training in Chip Edge regarding physical design domain. And afterwards, I'm trying for the job.
Good. How long have you been trying for the job?
Like this VLSI or
Yeah,
before?
VLSI. PD?
It is 5 months.
5 months. Okay.
Yeah.
Fine. What was your BTech project?
It is a multi-level inverter.
Okay. Like, what was it designed? Like, what was the aim for the design? Like, what was it designed to?
Actually, the output, whatever the output we are getting, there should be distortion like less than like 5%. Sine wave should be. So we basically designed this multi-layer inverter from scratch. Like we etched this PCB board and we soldered these thyristors. We made connections.
So, wasn't it an existing one multi-level? Are there multi-level inverters existing in the markets, or you tried something new in that?
Actually, when we built, we used H-bridge multi-layer inverter. Then right now, I do not have any knowledge about if there are.
Okay.
But
Fine.
there are multi-layer inverters. But what types, I do not know.
Okay. Fine. What are your best areas in electronics? Like, which subjects are your best at electronics?
I would say like in digital, I'm good with gates and optimizing gate usage logic. And I'm also bit good. Like I also trained in for gate for 1 year after BTech. So I would say digital I'm okay and analog is also I'm fine.
Okay. Any idea about CMOS theory?
Yes.
You're good at CMOS, right? Because you have worked on the same project. You use inverters, means you should have an idea of.
Yeah, I have basic knowledge, but not in depth. Yes.
Fine. I'll pick a question from there. You will design a CMOS inverter. Okay, you will be having a CMOS inverter. You will have two MOS. Okay, what will be the top one that will be driving VDD? What MOS will it be?
PMOS.
PMOS. What's the bottom one that will be grounding?
NMOS.
Okay, fine. Now both the inputs are shorted, and you are given a input for that, and you are driving the output from the source of the source and drain connectivity of the two MOSFETs. Okay. Now you are getting an inverted signal. Whatever signal you are giving, you will get an inverted signal, right?
Yes.
Okay. Now the thing is, I'll interchange these two, PMOS and NMOS. So what happens when you interchange the PMOS and NMOS?
What happens if we change PMOS to NMOS?
I'll interchange them. Instead of PMOS, I'll put NMOS, and instead of NMOS, I'll put PMOS.
Okay, then I think negative would be displayed. Negative value.
What kind of negative value?
Like if the output is VDD, it would be minus VDD. Like
Okay. Then what happens if the VSS is coming?
VSS.
Are you attending from mobile or are you attending from laptop?
Laptop I'm attending.
Okay. Do one thing. Take a work pad, like whiteboard. Try to explain the thing on whiteboard. It will be easy. Draw the inverter.
Yeah. Can
No,
you
not
give
physical
me a
one.
2?
You have an option,
Yeah.
right? In the laptop only, you have the three dots,
Yeah,
right?
yeah, I do have.
Click that and
Yeah,
you will get a whiteboard
yeah.
thing. You press that and check you can get it.
Share people.
Share it.
Yeah.
Yeah.
In my mouse, actually, I do not have mouse with me.
Okay. Fine. Do
Okay.
one thing.
Wait a minute. I am trying to do this with me.
You haven't allowed me the request to access your whiteboard.
Uh, okay, it is shared with VLSI. I did not get you. 1 minute. Editor. I'm only getting option for VLSI for all only. Hello,
Uh,
anyone with? Okay. Yes. Now I think you'll be getting.
Now I got the new one.
Yes,
Yeah,
yes.
I'm able to see your board. Continue.
Yeah. I will draw. Uh, so basically, if it is normal and most, this would be drain for PMOS and this would be drain for NMOS. And if it is interchanged,
So which one is now PMOS?
actually this is PMOS, this is NMOS. If you
No, I'm not
interchange,
seeing any of the mouse marks on your.
uh, 1 minute,
Yeah. Okay. Okay. Now it's good.
that is NMOS.
The top one is PMOS.
Yeah.
Fine. Continue.
So inputs would be like this. So if I interchange this, um, VDD, this is the gate you're telling.
Mm.
This is VDD and this is source. If I interchange and this would be output, so it would become it is actually pull up and pull down. If it pull downs, then
I'm giving you a edit request. You accept it. Got any?
yes,
Yeah.
1 minute. No, I did not get any edit request.
Wait a minute. Uh, Give me a second. I'll share my uh, Jamboard.
Interchange. Drain. Okay, this is the drain. This is the drain and source.
You got any link?
Yes.
Okay. See, this is your PMOS. This is your NMOS. This is ground. Can you edit it now? You might be having a option to edit there.
Yeah, I can edit.
Yeah. Now explain this. Now how can you change this? This is input.
Okay.
This is output. Okay. I'm leaving my mouse. It's up to you now.
Okay. So if I interchange,
Hmm.
actually this is
No, I can't.
okay.
See.
Okay.
You have to share that.
Share.
The on the top right, you will be having share. Got it?
Yeah, yeah.
Yeah. No, you shared yours. Fine, fine. Continue, continue. Let's not waste time. Continue.
So if I change, actually, the topmost in PMOS, the topmost will be like drain, and the outlet would be source,
Hmm.
and that source would become drain to this, and this will become source. Give me a minute. Can I explain in my board only? Actually, it is.
Yeah, fine, fine. Whatever.
I can. Now, can you see my?
Yeah, I'm seeing your board only.
So drain to source, and this would be drain here, and this would be source. And if I interchange, sorry, this is drain, and this is
Hmm?
source.
Sure about your
Yeah.
terminologies. You will connect two sources
Source,
together.
drain. Sorry. Output, NMOS output is source, and no, I think this is drain source. Okay, this. I'm confused now.
Fine. Okay, we'll move forward.
Yeah.
I'll give you a hint now. Try to understand that hint. Let's see if you can get that. Okay.
Yes.
Thing is, you will have a. So, yeah. Can you see my screen?
Yes. I
Yeah.
think.
Fine. The thing is, see. Uh, Consider what will be the output for the CMOS inverters.
It would be inverted, right?
Yeah, yeah,
Like
I
if
know
I
that.
give A as input,
Got it.
output
Got
would
it. The thing
yes.
is, what would be the output in terms of active or passive elements?
Output terms of
Active or
active or
passive? Active or passive? Which all do you call as passive elements and which all do you call as active elements?
active, which gives like which is source.
Hmm. What do you
Like
mean by
VDD
passive
is
elements?
active here, which gives like which is like source, which would not
Hold on, hold
require
on, hold on,
any
hold on. Passive elements, resistor. Okay,
capacitor and inductor.
you call this passive elements. What do
Yes.
you call active elements?
Like current source, voltage source.
Good, good. So, what would be the output here?
What could be the output is, yes, output here is voltage.
You have to work on your basics. Okay,
Yes. Okay.
this will be the output. Now the capacity output will be there. I'll give you another hint.
Yes.
You need to charge this and discharge this. By this, your inverter works. This is how inverter works. Now, what
Yes.
happens if you interchange NMOS and PMOS?
Um, then it would become reverse, right? By this we are charging, and through this we are discharging. So what would
For
happen?
by which one you are going to charge?
By PMOS we are charging.
Charging.
Yes, through NMOS we are discharging normally.
Discharge. Good. Then what happens if you reverse these?
If we reverse this through NMOS, we would be charging. PMOS would be discharged.
How can NMOS charge? Okay, one more hint for you. Okay, have you heard about perfect pass, perfect one, perfect zero?
Perfect 1, perfect 0.
Yeah. What does
No,
NMOS pass? Perfect zero or perfect one?
like perfect 1 means like logic output is perfectly 1 without any distortion. Logic would be in 1.
Fine. Okay. I think you're not getting. You work on your basics. I'll just explain this. Okay.
Yes.
This is PMOS. This is NMOS. Okay. You're connecting these two. Okay.
Yes.
Input. This is your output. This will be the capacity output. This will be the ground. This will be the output. This will be the VDD. PMOS. Okay. If you convert this into this thing, what happens is that when VDD flows, this will charge. And the charging path for capacitor is this. So this passes the perfect one. Okay, what happens at this time? At that time, NMOS becomes open circuit.
Okay.
Open circuit. Okay. If this becomes open circuit, it becomes like this. Okay. This will be. This is how your circuit looks when it's charging.
PMOS is on.
This charges. Okay. Once it is fully charged, this becomes open circuit because this passes perfect zero. Okay, this becomes open circuit, and your circuit will be like this.
Yes.
You will have a discharging path like this. So your charge gets discharged like this. This is your working. Okay.
Okay.
You interchange this. Your to charge, you won't pass perfect one. So what happens? It becomes infinite resistance. So your capacitor won't get charged. And if you pass perfect zero, at that time, this will not pass perfect zero. Like at this time, this becomes open circuit, and your capacitor still don't have any path to charge or discharge. Understood?
Last point, can you repeat?
See, first, okay.
Like, why can't we provide a perfect one to charge?
Okay, I'll come in the other way. Okay.
Yeah. One in the sense like VDD.
Yeah, VDD. VDD is your 1 and VSS is your 0. Okay. So you're giving input.
If we interchange, still it is connected, NMOS is connected, but why can't we perfectly provide?
Wait. See, this provides perfect one. Means it passes perfect VDD. Okay, and every time the current chooses the least resistive path to flow. NMOS is resistive to perfect one. Okay. PMOS is resistive to perfect zero. Perfect zero in the sense you need a path to discharge. That's called as perfect zero. So it won't go like this, or it won't choose the higher potential way to discharge the current. So it will flow here like this. Understood?
Yes. So what would be the output then?
If you interchange, if this becomes NMOS, you are getting a perfect one from up. NMOS is highly resistive to perfect one. So if it is highly resistive, what does it do? It becomes open circuit.
Okay.
At that time, your capacitor will look like this. If your capacitor is not charged, you won't have anything to discharge. So you don't have a charging wave also, waveform, or discharging waveform also.
Okay.
And for the perfect zero, your PMOS is resistive. So even though if you write perfect zero, it becomes open circuit, and it will choose. You won't have a path to flow.
Okay. Fine.
Got it?
Yes, I got it. Thank
Uh,
you.
okay, I'll choose your digital subjects only. We'll pick digital questions. Mm. What do you mean by a gate?
A gate.
Gate.
It provides some output if you provide input as per the logic you have given.
As per the.
Logic you have given.
So, what can you summarize with that? Like in a sentence, something specific with the gate.
Like functionality, it executes some functionality.
What functionality? I need a proper answer. Just one line answer correctly. You're like
Its output,
repeat again.
it would be giving output. It would be giving output to the input
You're lagging. You're lagging.
as per the functionality.
Yeah, now it's good. Now it's good. Continue.
Like I said, like
Repeat it. I'm.
output, you would be getting desired output whatever you want. You can obtain by gate. Desired functionality you can get.
Repeat it, because the thing is, whenever you're
Of the
speaking
inputs.
for the answer, at the same time your system is lagging. Like
Desired functionality you can achieve with gates.
Sorry, didn't get you. Repeat.
Desired functionality you can achieve with gates with the given inputs.
The first answer was correct. Actually, you said something correctly at the first, but you said it in another way.
Logic.
Yeah. The gate is nothing but a logical thing, a logical block which provides the output based upon the input, based upon the logic for the from the input. Okay, fine.
Okay.
What do you mean by flip flop?
Flip flop. As in like definition.
Anything, just define a flip flop.
Flip flop definition. Flip flop when getting the desired output with the given timing.
Hang on a second. Hang on.
Yeah.
Yeah. Continue. Sorry.
No problem. Trigger. Like achieving desired state with the help of clock.
Just define flip flop. What do you mean by flip flop? What does it do? What's the type? What's the difference?
Like you can get desired output, right? From with the help of like it is like positive edge or negative edge with regarding time.
Flip flop is a storage block, storage element. It's a 1-bit storage element, right?
Yeah. Yes.
How does it work?
Like you provide input and based on the previous input, it would
D flip flop
give you
doesn't work
output.
on the D flip flop doesn't work based upon
No,
the previous
as
input.
per the input, yes.
Then what's the
No.
difference between gate and flip flop?
Gate and flip flop. As you told, like gate does not have storage element, but flip flop does.
How does the gate, flip flop store an element?
How does flip-flop store? Flip-flop store an element through capacitance, right? It charges. It charges so that it stores as logic
If
one.
it charges, it needs
Discharges.
to discharge, right? So how does it
Yes.
store at that time?
How does it store? Capacitor is like storing thing, right? If it is charging, then it is storing as logic one. And if it is nothing,
But immediately
there
it's
is
going to
nothing,
discharge,
then
right?
it is.
After that.
It's going. Sorry, I cannot hear you.
After charging means if the capacitor is charging and storing, it's going to discharge, right? So how do you call it as a storage element? It's going to discharge, right? It's not going to hold.
It would discharge.
Sorry.
If we provide path for discharging, then only it discharges, right?
Then if you keep on charging, it would burst, right? If you don't provide a path and if you keep on charging, it would burst, right?
Yeah, but state changes, right?
No, you're
But
not meeting
it won't be continuous logic one.
I'll give you a hint. What are the pins for the for a flip flop? What all a flip flop has?
Input pin and output pin would be there, and clock and selection pin.
Selection pin. You're confusing yourself with the.
Sorry, that is mux. Decode. Only clock would be there.
Only clock. Okay, what are the 3 pins? You said like input, output, and
Clock.
okay, fine. Now you have the hint in whatever you have said. Try to get an output, like an answer from this.
Getting output from the given input with the help of clock.
What's the main difference between a gate and a flip flop? Main difference.
Timing, you'd be having clock, right?
So you got your hint. Now tell me how
clock,
does the
based on clock only output. Based on the clock, you would be generating output from the given input.
So you're saying that based on the clock, you are going to generate the output based on the input. Okay, you're near to the answer. Now tell me how does the clock, how does the flip flop store the works as a storage element? Like how does it store a bit?
How does it store a bit? As in, like I said, like it doesn't use capacitance. So is that out of question?
No, I'm just asking you one thing. How does it store an element? You answer me to the point. It's okay. Whatever way you approach, that's okay. You come from CMOS theory or you just come from flip flop. It's fine. Just give me the answer. How does it store?
Like if you use CMOS, then it would be charging through PMOS and capacitance would be charged. Capacitance only it would be coming at last. And then it would discharge through NMOS if the logic changes.
I'll give you one more hint. Let's see. I have to fresh up everything. I have to go through everything.
Okay.
We'll consider this as D flip flop. What is the functionality of D flip flop?
Whatever the input is given, output would be the same.
Same. But what's the functionality then?
It is exclusive or of
No, you are going out of the topic. Fine. I'll explain. Try to give an answer from this. Now, can you tell me what clock is this? What type of clock is this?
this is did not give me. It is this level trigger.
How can a flip-flop be level triggered?
Latch. Okay, latch should be level trigger. But you did not mention if it's positive or negative. Did not.
You can see it by the diagram, flip-flop diagram itself. We can identify it's a positive or a negative.
Okay, it's positive. It's positive.
How did you define it as a positive?
Like if there is one more like circle here, it would be negative H2.
One more?
Like in the arrow, if there is any circle there, it would be negative.
The arrow, if this is means it's a
It's negative.
Okay, fine. This is positive edge triggered. Okay. So what's the function of D flip flop? It's a delay. We call it as a delay. Delay flip flop. Okay. What does it do? It delays the output.
Yeah.
Understood. Now what happens? You are giving like anything to your sorry. Okay, anything to your okay. This is your this is sorry. Should I have drawn input correctly?
Okay, that is input.
This is your input, okay? Understood?
Yes.
This is your output. What does D flip-flop do? It delays the output. So if you are giving input, it should come output, right? The output should come, right? See, here you are occurring a clock pulse. You don't know what's the previous. So what happens that it will stay till here. Okay, this is 1, this is 2, this is 3, this is 4. Okay. So here input A, B, C, D. Okay. Now what happens is that
Till next trigger, it would be positive. I mean, one logic one.
What happens is that here you don't know what's the output here. Okay. What it will do is it will trigger in the next one and gives you the
Okay.
Okay. Now what happens? A is here. It's not giving immediately because it's delaying by one bit. Okay, it's delaying by this clock pulse.
Okay.
Like this. So it's triggering here and giving the output. What it is doing, it is delaying. So it's called as delay flip-flop. Delay flip-flop. Okay, here A, here B. Okay. Now what happens is that your input is getting charged here. And it is discharging at the second active edge. So what happens for the time period of this T, your logical 1 is stored, means A is stored here. So what happened here? From this period to this period, A is stored here. It's stored, right? It's stored a bit. If the input is 1, it's storing 1. If the input was 0, it would have stored the 0. So it stored a bit, right? How did it store? It stored a bit. But what thing is, it stored it only for the time period of T.
Okay.
Understood? I have to brush up on these concepts a lot. These are the basics questions. Before they jump into PD, they will ask this. Okay. Now, what do you mean by slack?
Slack. It is like useful skew, right?
What do you
No.
mean by Slack?
Slack is like can I tell it in like definition?
Yes,
Launch period.
anything. As ever as you want, you can say.
Launch time minus if difference between launch and capture is positive, then it is required. Slack is there.
You are saying set up Slack. I'm just asking you to define a Slack.
Slack is in like that is the remaining time you have after you use
What is
set up.
propagation delay?
Propagation delay after you after the clock pulse is generated and before it is captured by like capture flip flop, the delay which is happening between is propagation delay.
What do you mean by propagated clock then?
Propagated clock and propagation delay. Delay is in like signal wise, signal delay. Clock propagated clock is clock related to clock. From source to capture. No?
What do you mean by setup time now?
Setup time. Like data data should be stable before it is being captured. Certain amount of time before it is captured, it should be stable. And then that would be setup time.
Then what do you mean by setup Slack?
Setup Slack. It is like buffer Slack you would be having, which you can use it to adjust the time. No?
What do you mean by setup window?
No, I do not have idea about setup window.
Anything about hold? What do you mean by hold? Hold time, hold Slack.
After the data is kept, it should be stable for certain amount of time for output to be stable. That is called hold.
What needs to be stable? Hello.
Data needs to be stable. The signal data.
Yeah, it's input or output data.
It's input data, right? After input, you receive. For setup, it is input. For hold, it is out. Both are input data, I guess.
What do you mean by hold window?
No, we haven't talked about Windows.
Hold time. You're lagging. Your internet is lagging.
Hello? Hello?
Yeah, I can hear you.
I could not hear you. Hello?
Yeah, I can hear you. I can hear you.
Hold window. Actually, I did hear the term, but it hasn't been taught to us in class.
What do you mean by what is a clock? Just define a clock.
Clock. Define clock. Clock is like the timing. It is related to timing, right? You will like generate clock pulse and it would propagate from source to the end, whatever the path you are given.
I'm just asking you to define a clock. Simple, just one line
It's
definition.
timing.
If I ask you what's your name, you would say your name, right?
Yes.
If someone asks me what's your name, I will say my name is Girish. I'll not say there was a huge something called big hill which was named something like this. I won't give big length. I'll just say specifically. You have to be specific to the answer. Okay, be
Timing
specific.
signal.
You
Timing signal.
call timing signal as a clock.
Yes.
Then you have a timing signal in everything. The output of a flip flop is a timing signal. It changes with respect to time, or it acts with respect to time.
Then I would say which triggers um, the element. Or
What do you mean by fan out?
fan out is like number of outputs it can drive.
Hmm. Just what can drive?
Gate
A gate can drive the number of
outputs.
outputs.
Output connections.
Okay. What do you mean by driving an output?
Like it can supply the required charge. Like whatever the output.
Fine. I'll ask you some questions about PD.
Yes.
What are the steps that are going to be involved in the PD area? Like, where do you start and where do you end in the process of PD?
Yes. First I'll import design.
Hmm.
Then afterwards I do floor planning.
Hmm.
Then I did power planning.
Hmm.
Then I did placement.
Hmm.
Then SCTS, clock time. Then I did routing. And at last, physical verification.
Hmm. So, what did you do in the floor plan?
I basically um, placed some macros. I have given aspect ratio, uh,
Hmm.
how much percent I'll be using.
Hmm.
And I created pins, like direction of the pins in or out.
Hmm.
And I also like created pitch between the pins.
Hmm.
And like after placing macros, I also um, you like end cap cells.
Hmm.
I I used, and then what did I do? Mm, yes, I guess done that in floor.
Have you heard about anything as fly line analysis?
Yes,
What do you mean by fly line analysis?
like what are the connections which are related to macros, from macro to macro or input pins to macros. We'll be checking the density, and based on that we'll be placing based on number of connections, and also length we'll be taking.
Heard about abducted and non-abducted?
Yeah, I did here. Like, abut and non-abut I had. Abducted, no, I did not.
Yeah, sorry. That was the same thing what I was wanted to ask you. Yeah.
Okay.
What do you mean by them? What do you do with them?
Like if there is any, if between any two macros, if there is space in between, it is called abut. If there is no space, then it is called
No, which one
abut.
did you do?
There is space in between.
So what do you call that? What do you do? What was your design?
I think non-abut.
Okay. What do you what did you do in the power planning?
We defined which layer is like VDD VSS, which metal layer is VSS VDD,
Mm,
and we defined base layers.
mm,
Then what we did is Mm, pitch width. How much would be the pitch and width? We defined that. And what did we do still? Yes, this filler cells. No, filler cells or tap cells. Tap cells, I guess.
Hmm.
Tap cells. We did use that. And then we checked legality at last after all this.
You did it in power planning only.
Yes, legality we checked in power planning. They made us check if there are any overlaps. Sometimes what happens is MA trail overlap with M9, so whole design should be.
Okay. How many standard cells did your design contain?
In one of the design, there are 33,000 standard cells.
Okay. Your macros?
4 macros.
4 macros. Okay. How many metal layers did it contain?
9 metal layers.
Okay. Can you tell me what does each metal layer did and what does each metal layer was designed for?
Yeah, like I'll give a brief. I exactly don't know what did you do. M1 and M2 are base layers,
Hmm.
and that are like used for like whenever we use like PMOS and NMOS, that gate connections would be related to base layers.
Hmm.
M9 I defined as VDD, M8 as VSS, like ground and power rails,
Hmm.
and in between these are used for M8 and M9 we used vias. Um, Basically everything is used for like connectivity, all other metal layers in between for routing purpose.
Why did you choose M9 and M8 for the power only? Why didn't you choose M3, M4 as power, or M5, M6 as power, or M7?
We can choose, but as per what I know, M9 and M8 have less resistance, and also the um, amount of resistance we get in M9 is less.
Very good.
And also uh, M8, M9 are used for like power and ground, and beneath that it is used for clocking clock signal metal layers and signal metal layers. Sorry, clock layers, signal layers, metal
Hmm.
layers.
Okay.
That's
Okay. What happens if you use multiple vias? Like, why do you use a
multiple.
multiple vias?
Yeah, we use multiple vias because if one of the via was like getting shorted or it is not working, then you can use other for connectivity. It would solve.
No, 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 no. You're wrong.
Mm,
Why do you use multiple
like
vias?
suppose if there is any short between other metal layers, you can if there is only one via, you cannot solve, right?
You can just replace the via. You can resolve the shorts. It comes in the LVS, yes. Yeah, LVS or DSs. It will show you an issue if it
Huh.
is shorted or if it is a problem. You can do that. You can replace the via. Can correct that. Why do you use multiple
Yeah.
vias?
For I think if there is any like issues like would there be any like antenna issues? No, antenna could gate. Electromigration. No, I have to recollect again. I
Okay.
just forgot.
What was the power budget of your design?
No, I do not know. I did not.
Like, what was your whole design consuming? What was the power your whole design was consuming?
Power. Okay, we used around like 5 volts maximum, and current is like um, 1 milliamperes. 1.5, 5 into 1.5. What?
Did you
4.5.
get any IR drop?
Yes, actually, we did get airdrops, but we did not solve those in our classes.
Why? The main thing was to reduce power, right? You have to look at IR drops.
Like we solved for LVS DRCs,
In
And
LVS, you can work for the airdrops also. Before that, you have to look after the airdrops. You have to bring the airdrops to the acceptable limit so that then you can proceed for the placement part.
we did look, but I do not
We
remember.
didn't resolve it.
Huh.
Fine. What did you do in the placement stage?
In placement, actually, when we are doing placement, they have shown.
Sorry, I didn't get you.
And
Your
they
video.
have mag- magnet placement.
Your video lagged. Can you start again for
Mag-
the placement stage?
magnet magnet placement. Hello.
Yeah, continue.
Magnet placement. We
Okay, magnet placement. What do you mean by
magnet
magnet
placement, and
placement?
afterwards, like optimized some cells would be the same functionality cells would be gathered together and they are routed optimizedly.
Okay, what do you mean by G cell?
Can you hear me? Can you repeat?
What do you
G
mean by
cells?
G cells?
No, I do not have idea. Actually, magnet placement, there is like scripting. He just explained me so and so happens. We just did execute once, but afterwards we did.
Did you go through the scripts like you understood the
Mm,
scripts?
yes.
Like what did the script do? Like what was the functionality of the script was designed for? Like what was it written for?
That in placement stage you are asking.
Yeah, script in placement stage.
Mm, what we did is we also formed like logical connections between created layers and power and ground layers.
You you did legalization in placement stage? Did you do?
Yes.
Okay. What does legalization do?
Legalization checks if the placement is correct, like if there are no overlaps
Hmm.
or if the spacing is proper or correct
Hmm.
between two and it does not exceed. And metal to metal spacing, it checks macro to macro spacing, rail to rail
Going
space.
back to the power planning legalization, I'm asking about the placement legalization. What does it do
Place
in placement?
placement legalization. How to refer? Placement legalization. Can I just refer once and tell you?
It's a boss interview. You're saying that you are going to refer and let.
Actually, I did jot down whatever points.
You have a sticky note there. You're looking into it and telling me.
Nothing is with me now. Have written in book, whatever.
Fine, that's okay. Uh, did you do CTS? Like,
CTS actually, I just heard from my other seniors that CTS actually involves solving certain fault capacitance transitions and all, and but actually what we actually is only we resolve setup and hold. That's it. This further there was no help from the team for at least we did not get any commands to add buffer also.
yeah,
It's
you
all
won't be
by
doing that.
ourselves. We just discussed and someone
You
helped
just
us.
need to analyze the reports in CTS, identify the false path, multi-cycle paths, do everything and report it to the senior managers. They will look after it. Like, do you have any idea what happens in the CTS?
In CTS, clock line. There is actually file. We group paths, right? Into out register to register paths.
It's analyzing the
No,
report.
we
I'm
don't.
not asking about the analysis. I'm asking
Okay.
about you are doing the STA, you as being an STA engineer, you are going to analyze those parts and all. You will do
Okay.
the
Okay.
analysis, you will report it to the senior team, and they will resolve the issue. Or if you are a senior engineer, you will look into those parts and you will resolve the issues. I'm asking what happens in the
Okay.
CTS. If you have any idea, tell me.
Um, clock. I do not remember the script actually.
No, 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 I'm not asking about the script. What happens? Like, what's the functionality or what's the thing that's
Okay.
going to happen in GTS?
Ideally, we define a clock, right, and would be estimating delays. And here we would be actually giving the clock, and we'd be seeing if the delays we have predicted is what we are obtaining. Clock routes also would be getting.
Thing is, in CTS, you will draw the clock to everything, like every element in your design. Okay, so at that time, your clock gets estimated. Before that, you'll be doing an estimation. Okay, at this
Hmm.
moment, you will have a routing done, everything, every other cells will be there. And at this moment, your estimated clock might vary. Like by routing the clock's signals, you will connect one macro to the other macro, or you'll connect from your clock to the routing. You'll have a propagated clock in between. You will have everything this connection. So at this time, some might happen in a single cycle, some operations, some might take multi-cycle, some might be a false path, some might be an invalid path. All this will be taken into consideration. You will mark them all, and this is what's going to do as a ST engineer. In GTS, the routing for the each and everything is going to happen. In that, you will do two ways. One is classic CCD, classic CTS, and another one is CCD, concurrent clock design. Okay.
Huh. I actually have one doubt.
Yeah.
You just mentioned like routing would be taking place in CTS, clock signal routing.
Clock
Then
routing will
when
happen.
okay, then in routing, signal routing would be
Routes.
taking.
Yeah, yeah. If macro is communicating with another standard cell, the macro and the standard cells will be connected. And for an example, if I have a seven metal layer design, I'll be connecting all the seven metal layers. I'll be using all the seven metal layers. In that, seven, six, and six and five are the uh, power lines, and one was the base, two was for standard cells, three was three and four were for clock routing. And actual signal routing used to take place in all the routes, all the metal layers. Signal route used to take place all the metal layers that used to uh, work in all the metal layers. It used to route each and every macro standard cells, connect them each and every macro cell
In
standard
M5
cell.
M6 also you'll be having signal
I,
layers.
I gave an example out of seven metal layers. Seventh metal layer was the from seven we would not have the access. So five and six were for us, and five was even was VDD and odd was VSS. So
Hmm.
uh, six was VDD, five was VSS, odd and even, and then three, four were CTS for clock routing, two was for standard cells, one was for base layer, your PMOS and what you said. Okay,
But why
and
is signal like signal routes related to all metal layers? Why is it not like
because
related like two?
you have to communicate to each other, right, each other macro and standard cells. So your
Hmm.
signal routes needs to happen. If you don't have a connection between the macros, how would you communicate? You have a block, you have a standard cell which is going to perform addition, and you have a standard cell which is going to perform multiplication. Okay, you give
Hmm.
you will give an expression to the input as an input that a plus b, or like a 2 plus 2 into 5. So how would they get an communication? See, if you don't communicate, A and B addition would be done, and you need another product, another number to do the product, right? So where will that go? So if they both communicate, the product of this will be given as an input for the other standard cell or anything. Just giving an example. This is not how standard cell works, but just giving an example. So that output will be given. Okay. This is what happens in the routing. So your standard cell macros, everything gets connected. Okay.
Yes.
You okay? I'll ask you one more question.
Yes.
What are the inputs for physical design?
Inputs for physical design.
Yeah.
There are so many. Verilog file.
What do you call
SDC.
the file as?
.v.
.v, I know, not extension. You call something specifically the Verilog file.
Specifically Verilog. Like gated netlist?
Yeah, GLN.
Okay, and SDC file.
Okay.
And we'll be giving tex file. Technology file.
Yeah, technology file.
Okay, and TLU file, TLU plus file.
TLU plus, okay.
And then LEF files.
Okay.
LIB files. .lib.
Okay.
And what more? I think that much I remember. Did I miss out anything? I think I mentioned everything.
You'll provide 8 inputs. One will be the GLN .lib technology file. Left TLU plus SDC physical library library.
I missed def file. Right?
Memories.
SDC?
India with respect to the tool.
India?
No, you will provide it if you are working on a tool, you will be fine. We'll conclude. Antenna effect.
Oh no. I just prepared this before. Antenna effect is like is it correct? Gate to what ratio? Gate to ratio. Oh no, I just reviewed before only. Gate ratio to this anode ratio, antenna ratio. The width of the charge we are providing, like gate should be able to withstand anode gate ratio. Oh my god, I don't know. Can you give me a hint, please?
No interviewer is going to give so much hints for you.
Gate, I know, like whatever the charge we are providing, gate should be.
The thing is, what happens? What happens? I'm asking.
What happens in antenna effect? Like gate should be able to withstand the charge we are providing. So the width should be.
I'll give you another hint. Okay, what are you going to do to resolve an antenna effect? Them on the metal layer only. So when you pass them on a metal layer, minute ions, like minority ions, will be created. So those will flow through the metal layers. So that will damage. So you have to make sure that these ions get settled down. So to get them settled down, you will cut the metal layer and give it another path. Okay, you will cut the lower metal layer and give a path to the upper metal layer. So these ions get dissolved. Okay. These ions get settled. This is called as jumper wire method. Okay, this one. If this is
So
sorry, you said something.
yeah, nothing. Please
Okay,
you
this is called
continue.
as jumper wire method. Post this, if you are at the metal 6 and if you are facing this, and if you don't have a metal 7 layer access, then you can use the diode insertion method, where you will insert a reverse bias diode from the source to the ground. Where what happens at that time, whatever the ions that are present or that are coming to damage the uh, gate oxide will flow through the reverse bias diode and it will go through the ground. Okay. So this will be the mandatory question in if you are going for a PD domain or PD roles, and how you will reduce it. There are a lot of other questions will be asked. You have to be prepared for that, and you don't need to worry about the ratio of that thing. Exposed gate area by exposed conductor device by gate area, oxide area greater than antenna ratio. It's a ratio that will say that are you having a antenna effect or not in your design. Like is that it's like you have to you'll decide based upon that ratio. Okay, you have to explain what do you mean by antenna effect. It's an effect that happens due to the ions or leaked ions uh, during the plasma etching stage. That's it. Okay, that will result in the gate oxide damage of the gate oxide. Hmm? Prepare well, you have to go through
Okay.
the digital basics again, analog basics again, CMOS theory again, PD again completely. You are somewhat good in PD, but you have to revise everything. Go through whatever, start with basics, like you start from digital, cover everything a day, like one part of the digital, like basic combinational circuits you finish off one day, sequential circuits the next day. Third day you revise combinational and sequential, then go for the CMOS theory, finish it off in one day. Then you go for the this PD. You pick floor plan one day and try to understand everything on the floor plan. I'll share some websites where you can study everything. Those are very good websites that will teach you from first to end. Go through them, what
Yes.
happens in them and all, and pick floor plan one day. Go for placement one day. Go for power planning one day. Go for CTS routing one day, and then STA. Try to solve problems on STA also. And
Yes.
try to analyze how the reports are going to be generated. If you have the reports of any project which you have done, try to analyze those reports. That's more than enough for you. Okay,
Yes. Yes.
you prepare well, because I'm sorry to say this, but if I were an interview, I would not select you. So that's the one reason why I am saying is that you have to improve. That's it. Okay, that's the only
Yes.
reason why I'm saying. And whenever you are attending an interview, make sure that you have stable internet connection and you have
Yes.
the perfect view of whatever you are having, and you have to sit like somewhat comfortable and straight. If you sit like this or if you sit like this, the interviewer might not me. The interviewer usually consider as a candidate possible candidate is not interested, and they
Yes.
leave. Yeah, make sure you are sitting in a well lit place so that your face is visible to the interviewer. Make sure camera angles are all good. Make everything clear and do it. Okay. Okay. Fine. If you have any questions, ask
And
me.
in digital basics, what should I concentrate? Like sequential mentioned basic definitions like the like logics also.
No, no. What I'm saying is that definition you don't need to concentrate. You don't need to by heart the definitions. What I'm saying is that if someone asks you about something, you have to define it in a very simple and understandable way. So that if you say that what is gate, gate is nothing but a element which takes an input and provides the output based upon the logical operations or based upon the logic or functionality. That's enough. You don't need to break it even and say like it has two inputs, it has one input, this do no, you don't need to do that. Just give a line and give an example. Just be specific to the answer. That's it. You should not take or drag it, and you should not think too much on the answer. If you don't know, you just say, no, sir, I don't know. That's enough, because
Yes.
no one expects you to be 100% okay. You can be okay. Interviewer asks for you, answers from you. They expect answers from you. They are not interrogating you. They are interviewing, right? So they expect the answer. They give you the hints. Try to catch those hints. Okay.
And one more doubt I have, like you mentioned like setup window, hold window, right? And also like 2 3 terms you have mentioned. Can you just explain that?
Okay,
I
setup
will.
window is nothing but your setup time. Okay, the thing is, you have a clock. Okay, before the active edge, you need your data needs to be stable for some period.
Yes.
That's the setup window. Means setup
And
time.
it is like input data only you are telling, right?
Input data. Input data. After your
Yes.
active edge, you have some time where your data needs to be stable. That's the output data.
Yes.
Okay, that's the output data that needs to be stable. That's called as hold window.
Okay.
Okay, setup time.
Then then
Both.
slack is hold
Setup
slack.
slack is your slack needs to be positive. That is a required time minus arrival time.
Yes. Yes.
Okay, AT minus RT. Arrival time minus required time for setup.
But
Arrival time should be
if
greater
I
than the
have
required.
if I have to define slack, then what would I tell?
You have to say that the sorry. You have to say, if they ask you as a setup Slack, you have to say tell the same thing. Setup in setup Slack we have required time minus arrival time,
Hmm.
and arrival time should be less than the required time. So it
Okay.
arrives before the setup window, and the during the setup window the data needs to be stable. In hold time, you have to say that. The hold window in the hold window, your arrival time should
I'm
be greater than the required
required.
time,
Required time.
because that needs to be stable for that duration. Okay,
Yes.
yeah, that duration it can be stable, and after that it goes, it can pass on.
Okay.
So
And one more
that time
last.
that's called as hold slack. So your setup slack needs to be positive. If it's negative,
Uh,
slack is violated. Means setup is violated.
Same. Whole slack also should be positive, right?
Yeah, and if you use the formula in a reverse way, it should be negative.
Yes.
80 minus
Same thing
RT
if we
means
are using.
80 minus RT means here positive, here negative. 80 minus
Hmm.
RT minus 80 means here negative, here positive.
And you also mentioned um, propagation delay and some like same word with. Uh, can you
Propagation
repeat?
delay, propagated clock.
Yeah.
Yeah, propagation delay is if you have a AND gate, the
Uh,
time taken for the AND gate from input to give an output is a propagation delay. Simple. If I need to say in a simple word, the time taken by a gate to give gate from input to output. So whatever the time it takes to you. So for example, zero point 0.2 millisecond or zero point 0.2 nanosecond. If a gate takes a 0.2 nanosecond, it's taking 0.2 nanoseconds to process the input.
okay.
Propagation delay. For a gate, propagation delay of a gate means the gate is taking such time. Okay.
Okay.
Propagated clock means you have an input in your design. You have an input pin, clock pin. Okay. For that, you will provide externally the clock. Okay. After that, it will travel. Okay. You can't provide clock from one clock pin to everywhere. You will have branched out. Like you will branch the clocks everywhere. So you'll
Yes.
propagate the clock. You'll propagate the clock from in clock pin to another area where it gets distributed. So
Yes.
that's called as a
Then,
propagated clock.
like, if I have to define, how will I define that?
You can do it in the prime time, this prime time, like define clock, propagated, something you can do. There are commands for that. You can, if you have you used the prime time PT shell?
Yes, I did use.
In that it will be the propagated clocks. Some there are multiple clocks, propagated clocks, etc., etc. And all. You can use those clocks. You can define those clocks, and you can mention. Okay,
Okay.
you have to work on PT shell also, but you don't have access, I guess now.
Yes.
Fine. I'll share some links for you and some notes also. Start preparing, okay? That will be helpful. I think I have shared in the group once. I think, wait, just a minute. Tejaswini, right? Yeah. Okay, we had an interaction previously. Okay, I shared my resume to you.
Resume?
Okay. I have already shared my resume to you once. Okay, I'll share the notes and all to you. Keep going with that. That will be helpful for you. Okay.
Okay.
Fine. Shall we end the session?
Hi.
Fine. Okay. Prepare well. Bye.